Hello, welcome to my channel. So in this video is the first example of the topic of curvilinear motion. Okay, so this will start off very simple question, and we will go through the solution together. Firstly, let's understand what is the problem have state had what is the problem statement. Okay, so the problem said that we have a hydraulic cylinder rotate around point O, which is this point. Export the length of length L. Okay, is the movable rod, which it can go longer or shorter. Okay, depend on the increase or decreasing rate. Okay, so it said that this cylinder rotate at constant rate of theta dot for 45 degrees per second. Though that means in 1 second it rotated 45 degrees. In 2 seconds it rotate around 90 degrees, for example. And the length L is decreasing at the rate of 100 millimeter per second. Okay, that means that in 1 second this length is shortening by 100 millimeter. Okay, so they asked us to determine the magnitude of the velocity and acceleration A of an n b when L equal to 150. Okay, when this L equal to 150 millimeter, we would then determine A and V. Okay, assuming that the distance from point O to the pivot of the beginning of this rod is 270 millimeter. Okay, so firstly we try to determine the velocity vector. Okay, before doing that, we then always draw the frame of positive R and positive theta to indicate the components of velocity here at point B, the interest point. We would then describe the velocity that point toward positive R as VR, the one that point toward theta as V theta. We then determine velocity V by this equation. Okay, so we know that this equation is we have a magnitude of VR equal to R dot, and then the question already giving us the constant rate of R, which is 100 millimeter per second. I put the minus sign here because it said that it was decreasing. That means this length is then going toward this direction. Okay, so that means it go against positive R. That's why this minus sign is up here, and it's constant. So we can see that if we would then determine the value of R double dot, it will be 0, right? Because the differentiate of a constant will be 0. Okay, then we can clearly see, safely say that the velocity R has a magnitude of minus 100. Now look at V theta. Okay, what is the velocity in theta axis? So firstly, V theta equal to R theta dot, and theta dot is already given by the problem that it was 45 degrees per second as a constant. But again, so we would then know that if that we have to find the theta double dot, it will clearly be 0. Okay, here. So, and the V theta equal to R and theta dot, right? But R here, we must not forget that we have to take into account the distance from rotation axis to here and then plus the length L. Okay, so the distance from point O to here is 270. Okay, the distance from here to B at the given status, they said the L will be equal to 150. Okay, so that means the total or the actual radius will be 270 plus 150 times the theta dot, which is 45 degrees per second. Okay, but we will not use the degree per second to calculate the velocity magnitude. Okay, because the unit degrees is not actually valid when we try to determine the what we call the displacement in. Oh, sorry, we would try to determine the velocity value So we would then have to change this degree into radians. Okay, so this short kind of information about it is that the degrees that we use so casually, why we have to change to radius. Okay, so radius is a mathematical expression that the exact ratio of circumference and area, sorry, exact ratio of the circumference and area of circle. Okay, but the degrees unit is what we conveniently say. Okay, because we cannot use just like pi over 2 or pi over 6 to indicate the angle in daily life. It would be too complicated. We just say 90 degree or 30 degree, 45 degree. Okay, that is more simple way. But in the calculation, we should always convert it into the radians unit. But that also depends in the way the question was asked. In this case, calculation of the velocity, we use radians, not a degree. So to convert that, we use this 45 degrees per second times the pi radians divided by 180 degrees. We would then cancel out this. Okay, we would then cancel out degree here, and when we're left with radians and second and millimeter. Okay, but radian again, it doesn't really have meaningful unit that was sorry, it's basically no unit at all with radians. It's just the way we described pi. So if we perform the calculation here, we would get that V theta equal to 229.86 millimeter per second. Okay, so here my the velocity magnitude of the velocity. Okay, VR square plus V theta square, and then under the square root we would get the velocity magnitude of 344, for example. Then how about acceleration? Okay, acceleration, we use the acceleration equation we have previously derived and discussed, and then we substitute the component or the parameter we know. Okay, so firstly, the easiest one, r double dot is already 0, right? So we doesn't have to take it into account. And then the theta dot is constant, so that means theta double dot would be 0 automatically here. So then we substitute the rest of the equation. Firstly, look at the component AR, that is equal to r double dot minus r theta dot square. So again, I tell you that this component is 0, so we left with only this term. We substitute r and theta dot accordingly, so don't forget to use the theta dot that is in the radians unit. Okay, you can always see if it convert to radian, it has to have a pi in there. Okay, then in theta axis, a acceleration in theta axis would result in this value. Then we cancel out this term because the theta double dot is 0. Then we left with only this term. Again, don't forget to change the theta dot into radians, and then we'll get this value of the AR and A theta in magnitude. So we would then determine the magnitude of the total acceleration by the square of the magnitude in each component. Under the square root, we will get 202 millimeter per second square. Okay, and that is the end of the first example. Okay, so please be familiar with these two equations. We would then use this one a lot, but be sure to watch the previous video so that you can understand clearly of how these two came from. Okay, so that's it, guys. That's it for today. Thank you for watching. I hope you learn how to solve this problem and understand the core concept of how it was solved and how we interpreted the problem. Okay. Thank you for watching, and see you guys in the next video.